Ladies and gentlemen, while Chinese industrial development has been extraordinary, the U.S. performance has lagged. Here to discuss Reindustrializing America are Austin Bishop, co-founder and CEO of the New American Industrial Alliance, Ed Mehr, CEO and co-founder of Machina Labs, and Kevin Czinger, founder and executive chairman of Divergent Technologies. The conversation will be moderated by Rob Atkinson, president of the Information Technology and Innovation Foundation.
Oh, somebody's talking. I got it. All right. All right. Good to go. Everybody hear me?
Hey.
Hello. All right. Everybody hear me now? Hey, beautiful. Okay. I think we have 6.3 minutes, so we're going to really be brisk. Thank you all for joining. I'm Rob Atkinson. I'm president of the think tank located a block away. Information Technology Innovation Foundation. We've worked extensively for a long, long time on U.S. competitiveness and industrial policy. I'm not ashamed to say the word. I'm proud. Industrial policy.
You're brave.
Thank you. I'm not brave. I'm stupid. We just issued a report last fall looking at 10 Chinese industries to assess how innovative they are. And one of them was on the robotics sector. And while the Chinese overall aren't as innovative as we are, or the Germans, or the Japanese, they're really catching up, and they're driving innovation dramatically. They installed more industrial robots last year than the rest of the world combined. They invest about 12 times more in industrial robots than we do when you control for wage levels. So this is a big challenge, and as much as you can have a pro or con about tariffs, at the end of the day, the only way we're going to reindustrialize is by cutting costs and making more innovative products. Those two things, sort of process and product innovation. So one statistic before I introduce the panel, which I think should be a cause of caution or worry. The National Science Foundation just came out with their Center for Engineering and Science Statistics about 2 weeks ago for 2022. And they asked companies, how much do you adopt robots? And if you look at manufacturing, 8.3% of US manufacturers have adopted robots. And then you ask them, why didn't you adopt it? 55% said, we don't think this technology is applicable. I may not be a CEO or an engineer, but clearly 55% is way too high. So our companies aren't really using these technologies, and that's one of the things we want to talk about today as to why that's the case, but also these amazing new technologies are going to make it easier for companies to do that. And it's not just robotics, we're going to hear about 3D printing, but it's basically ways to radically improve manufacturing productivity. So on my immediate right is Austin Bishop, founder and CEO of the New American Industrial Alliance, a really cool group out of Detroit, right? Am I right?
We hold the summit in Detroit.
Oh, you hold the summit in
We're based
Detroit.
down the street right here in the swamp.
Okay. I love the swamp, by the way.
Can't hear me? Oh, there we are.
All right.
Hey, everyone.
The swamp is how we get stuff
We are
done.
not based in Detroit.
All right.
We're based here in D.C., but we hold the summit
You hold the summit there.
Reindustrialize every year in Detroit.
Okay.
I'm just going to hold it right here.
Aidan Madigan-Curtis, who's a general partner.
This is Ed.
We got Ed.
Aiden is
Aidan was there. Ed. Well, I'm an idiot. Ed, who's the CEO of Machina Labs, and Ed will talk a little bit more about that. And then finally, Kevin
Czinger. The C silent, Rob.
And lead inventor and CEO of Divergent 3D, which is a really cool company based in LA. So let me start by, Austin, you got this alliance, which I think is interesting. Everybody focuses, well, there's a growing hipness of hard tech or deep tech, which is real, needs to be there. And you're trying to sort of bring that all together, sort of the startup world, VC, government. What are you trying to do, and how's it going?
I'm just going to hold it, I think. Look, one of the things that tech companies haven't done for a long time is come to DC and build coalitions. For a long time, I think, especially the Silicon Valley-based companies have thought of DC as something that's...
Can you hear that all?
Yeah.
All right, thank you.
Zero-sum game. And, you know, we're not going to get reindustrialization done just by inventing an algorithm in a garage. I mean, Google was founded in a garage. I mean, a lot of these great Silicon Valley software companies were founded in a garage. But it's going to take way more than just Silicon Valley early stage venture dollars and innovations. That's where a lot of this stuff starts. But it's also going to take the massive private equity investments. It's going to take the infrastructure funds who actually, build the ports and the factories. It's going to take the banks who actually, fund the debt solutions to a lot of these companies so that they don't have to get diluted round after round. So by the time that these companies are able to exit, the founders don't own anything left. And it's also going to take partnerships with large heritage manufacturers and industrial companies. I mean, you go into the headquarters of some of these sleepy giants, and some of these people are more sophisticated than a lot of the early stage tech companies. So what we identified both with the Summit Reindustrialize and with NAIA was that no one had thought to put these people together, both the early stage tech companies and their venture backers, all the way up to the large heritage industrial manufacturing companies and the private equity firms and infrastructure funds that fund the building of their factories and ports and data centers and all of the above.
Let me ask you one question before we go down. We did a little analysis of the Small Business Administration a few years ago when the Senate was actually trying to reform it. I think it was 6% of SBA loans went to manufacturers. I think there were probably more liquor stores funded by the SBA, I'm not making that up, than the manufacturers, which is atrocious. Do you see the government playing a different role nowadays? You got the capital program in DOD, you get various things. Yeah. How is government playing a role? And also you have state and local governments too that can play a role and want to build startups in manufacturing.
Yeah, look, I mean, liquor stores play an important part of the economy in my home state of Ohio. So, but jokes aside, what's really fascinating about this administration is there seems to be a real willingness and openness to try new things, whether it's what they're looking at with Exim Bank, OSC, SBA, or DPA authorization. I will say, just to step back, like we believe that there's a lot that the government can do to help these businesses, but a lot of that also just comes from a smarter regulatory regime, because the one thing the U.S. already has, like, we already have the most liquid and adventurous capital markets in the entire world. A lot of these massive firms just want to know there's a risk-adjusted return to invest in these things. They're not running charities. So, when people ask, like, what can the government do, especially on the funding side, whether it's loan forgiveness or, or even picking winners and losers, making equity investments in some of these companies through this the sovereign wealth fund that some people are talking about in the Treasury, a lot of this is also just like, get the regulatory and permitting stuff right so that the investment class can actually go and build and invest in these companies. The cost to just pour concrete in this country is absolutely insane, and if you can reduce that cost and allow entrepreneurs and investors in the U.S. to play on a level playing field against their competitors in other countries, you're going to get a lot of juice out of that as well. But to get really to your point, though, I do think I am cautiously optimistic about what we're seeing with OSCs. Certainly, their program to provide leverage to investment funds has gone, I don't want to say without a hitch, but it's been really incredible how quickly that's moved, and now they're moving into providing similar product, but directly to companies. And I think, again, not going to hold my breath too much, but what we see across a number of parts of the government seems to be really, really exciting about ways that we can get more funding for great companies like these guys, outside of them just having to take 20-30% dilutive rounds over and over and over to their venture investors.
Great. So Ed, first of all, tell us a little bit about Machina Labs, but we've been hearing about robots. By the way, you remember that scene in the Graduate where plastics? If anybody asks me, I say robots. I'm quite serious. I just think, to me, robotics and automation, that's the most important thing. But it's been slower than we thought 10 years ago, partly because it's harder to program things, and you're still working on sense and vision and all that. Just sort of tell us, where do you think we are now, and are we getting to the point where a typical, maybe a $50 million manufacturer could say, yeah, I really want to roboticize my facility, and how does your company deal with or play into that?
Yeah, you're right. I think robotic has been in existence since 50s, 60s, more so maybe starting 70s. More manufacturers start adopting it. The main challenge though for adoption was that you need to program static programs into these robots, right? For every operation till today, you literally have to have expensive robot programmers go sit down, write the program. It's very specific to that manufacturing process. The moment you want to change your material, you want to change your design, now you have to redo the programming, right? So to some extent, it's actually for a lot of people was more complicated to adopt robotic technologies. And you can see like high adoption in very high volume businesses like automotive, which makes the same car over and over again. It's like, okay, it makes sense for me to go teach robots what to do because I'm gonna, for the next 2-3 years, I'm gonna keep making the same thing over and over again. But if you're in a defense business, if you're in a higher mix business, the challenge of programming the robots was bigger than like getting some people do the job. I think for the first time, now AI is in the place where we can start being more flexible and not having programmers write specific programs every time, right? So I think this is the key enabler, right? We had the kinematics for a long time, but for the first time, you have the intelligence. So that if you get a new design, we can automatically come up with the right procedures for that specific part. And that's what we're doing at Machina Labs, right? The goal is, can we move away from statically defined, hardware-constrained factories? Because today, if you really want to build a hardware product with traditional manufacturing, you have to build a factory specifically for it. The design, the material that goes into that is very specific for the product you're trying to manufacture. Now, that can be programming of the robots, but also a lot of tooling, dies, molds that you have to make that are specific for that product. What we're trying to do at Machina is, for the first time, create robotic system that just can get the design and then adjust autonomously to manufacture a new material, new design, without having to change any hardware, but also not having to go and literally program every robot, right? So we started from our process, which is sheet forming, which you enter the design, and then on the other end, the robot figures out how to make it. We added trimming, we added hole making, slotting, QC, so we're constantly adding more operation to our robotic system. So you can think of it as a factory full of autonomous robots that can figure out how to come up with the right procedures to build any kinds of parts. So in the morning, we can build automotive car panels. In the afternoon, we can make missile panels. And at night, when nobody's even in the facility, we can do landing gear doors for a military aircraft, right? And nothing in the hardware of the factory changes.
Yeah.
And allows you to be much more iterative than traditional manufacturing.
Yeah, that's interesting, because about 20, 25 years ago, there was a lot of talk about mass customization. So Harvard Business School and all, like this really cool idea. But your point about the high fixed costs with robots, it's hard to do that. My colleague, Suzanne de Trevel, who's over in Lucerne University of Management, Operations Management, she did some really interesting work that said if you can do some of this, you can still have higher labor costs than China, but if you can move from product to product, you can make some things now cheaper than you can in China because of that flexibility. My question is, how much of what you're doing, not maybe requires, but is helped if you can do data sharing with a bunch of different companies, as opposed to just a silo in the company who's using it? Does that matter or help?
Yeah, so I think you're touching on the right point, right? We see data is a very important enabler for being able to come up with these AI models that allow us to program these robots. We have things like ChatGPT, right, that everybody's using now. It has been trained on publicly available data, right? On data that's available on websites, on internet, right? And now it can basically talk to us almost like a human. The type of data we need to process material doesn't exist on internet, right? It's a physical world data. So we almost have to generate it ourselves. For a while, maybe we have been generating in the factories. As a matter of fact, actually, the old equipment don't really generate the type of data we need. But now we need to start thinking about how we generate the data we need to come up with the right models that can manipulate the physical world. That's some of the things we are doing. We designed our system so that it can generate every 4 milliseconds. It generates 120, 130 channels of data that we can use to create these models, these AI models. But it would be significantly much faster if you could pull resources across multiple industry partners, right? And that infrastructure doesn't exist either today to share the data. There's a lot of challenges in terms of sharing data because a lot of people think of it as proprietary, right? So that's definitely a challenge to resolve.
I want to come back to that because I think that's just a big issue in AI in general, of these sort of third-party intermediary anonymized data trusts that sort of say, hey, we'll help you. We're not going to share your confidential data, but we'll give you some knowledge and learning from that without sharing what part you're making. Kevin, so we're talking a little about robots. you're sort of a robot. What your company is sort of a robot. If you think about 3D printing, it's a machine that's sort of autonomous. But tell us about what you're doing, and also why potentially it's such a game changer. I mean, a lot of historically in manufacturing, at least parts manufacturing, you essentially first you did tooling, then you made a particular part, then you assembled the part, then you tested the part, and that's very time-consuming and expensive. And you're sort of saying, wait a minute, we can do that very differently. And you want to just talk a little bit about how you're doing that?
Sure. So the approach that we took, and the company's about 10 years old, we've raised about $800 million. We have about 450 employees. They're almost all scientists and engineers. Was number one, don't start with any existing point solutions. Take a total systems approach to fully digital, zero tooling, zero fixturing, design agnostic, fully digital engineering and manufacturing. And so the first 5 years of the company was spending about $500 million creating that system. That system allows you, based on a material card where we develop and take through material readiness, everything from aluminums for an Aston Martin crash structure, the frame of an Aston Martin, which we're delivering to Aston Martin right now in a normal road-going car, something people didn't think would happen for 20 plus years, to hypersonic, like materials, high temp resistant materials, to high strength materials for munitions. So we take a material card from that. We run using a combination of machine learning and deterministic algorithms, a perfectly optimized structure in 3 dimensions. Say it's a cruise missile system. Across that entire system, the system will be adding, subtracting material. It will be reducing parts by actually integrating what would otherwise be a fuel tank put in, routing, conduits, parts of that. That's all being generated, but what's key is you can create a perfect part, but it needs to be manufacturable and assemblable. So we're concurrently running and we build our own 3D printers, our printing process and our assembly process. So say you have a part that normally takes 6 to 9 months and several engineering teams to get to the sign-off, engineering sign-off. We're building that, say, in 15 hours of processing time. It comes out fully optimized, lighter, better performance. It comes out with its full manufacturer assembly instructions. It gets printed and assembled. That printer we built is design agnostic. Anything the system builds, from a Aston Martin frame to a McLaren hypercar suspension system to a Saab Defense micro torpedo to a Lockheed Martin cruise missile system, anything that's generated, that printer can print. It can move from one structure to another structure seamlessly. And then we've created a zero robotics programming system where we're using not the arm accuracy of it, but a completely different system. And rather than having fixturing in the factory, all of the assembly features of the structure are not built into the factory, but built into the structure itself. So this allows you, and what our plan is now, we have that factory that's in California. It's currently serving 6 major auto manufacturers, shipping parts, fully commercialized. We now have 18 production contracts we've gotten within about 18 months with aerospace and defense, with 14 different primes, including the big ones like Lockheed and RTX and the new Neo primes. Anything we do there that gets produced, we're going to start replicating those factories. So the idea is you have full design agnostic, fully digital network of factories that share data, but basically act as AWS acts for digital content. This is for actual physical structure. So the idea is use that not only for these large primes, but create for America that development network where we provide the tools, people generate, and then on demand anywhere we print and assemble for them.
So one question, and then if people want to ask a question, just go up to the mic. When you're a CEO of a company, you think you're going to make ice cream cones because your technology is so good for everything. But I assume there's an inverse relationship. The more complex the part is, the more difficult the tooling is, the more difficult the assembly is, and the higher value added, it makes more sense to do what you're doing as opposed to making that chair pretty simple. Is that right? And sort of, like I guess the question is sort of, at what breadth of, you're basically in the discrete part assembly business, taking that away, like you wouldn't be doing chemical plants or, you know, pickle factories. In that discrete parts manufacturing sector, what share of this technology do you think can ultimately sort of replace what's there now? Is it 25%, or it's a hard number?
What I would say is, if you look currently at munitions, kind of, let's look at aerospace and defense first.
Yep.
Basically most all unmanned air, land, sea, and space vehicles that I'd say are under kind of 10 meters long in length for our current system can be done. We're now starting to do propulsion systems and integrate those in as well. So, you know, that end we're doing things, you know, like actual warhead structure as well. So we're now adding and integrating in a lot of structure, but I'd say there, you know, the full range of existing munition missile systems, the new kind of affordable mass unmanned air, land, sea, and space, across sustainment, almost everything could be digitized and then printed on demand. All of that done much faster, better, cheaper, literally saving many billions of dollars and increasing readiness. In the car area, we've started out, you know, those car companies I'm talking about, Aston, Bugatti, McLaren, Mercedes, AMG, Porsche, higher end. We're not doing like a, you know, if you have a flat piece of same gauge something, that is not an optimized something. It's not a kind of multi-material, functionally integrated, multi-component system. For anything that fits that broad generic description, this is going to do it. And I would say within 5 years or so, we could do individual car models in the hundreds of thousands of units, faster, better, and cheaper than existing casting and stamping.
That's really interesting. If you have a question, just go up to the mic.
Hi, can you hear me?
Yes, go ahead,
okay,
please.
Great, thank you. So panel's called Reindustrializing America. Over the past few years, there's been sort of debate back and forth on does America need an industrial policy, et cetera. So first part of the question is just, do you have any thoughts on that debate? And if we, you know, what would you put in such a policy, or what would you recommend keeping out of such a policy? And then also, a lot of the technologies you've been talking about use a lot less human force, human power. So thoughts about what reindustrializing America looks like for the American workforce, and what the you know, human-machine pairing looks like, and what effects you think that'll have on employment, et cetera. Thank you.
Why don't we do you on industrial policy, and then we'll take one other person, because we got to go through.
Sure
so
thing.
Go ahead with industrial
just
policy.
At a high level, you don't get to not do industrial policy. It's, I mean, for a few decades, it's been certainly in this town. Some people are allergic to that world. Some people aren't. But other countries are doing industrial policy against us, whether we like it or not. You don't get to opt out of it. And other countries are sort of forcibly deindustrializing a lot of your industries by, whether it's through subsidies, currency manipulation, all these things. Choosing to opt out is making a choice. And so I'd love to catch up to tell you more about our specific policy priorities at NAIA, but we believe that, you know, you have to be in the fight. It's not one that you can really opt out of. Leave it to these guys to talk about the workforce stuff that they're doing.
So I can do the job one real quick, and then the job one is, I don't think we should care. Manufacturing doesn't have a wage premium anymore. We're not going to grow manufacturing jobs. We don't need jobs in the U.S. We got low unemployment rate. What we need is strong manufacturing to support the dual-use defense industrial base, and we need strong manufacturing to pay off our massive trade deficit in goods. So the idea that we should have a sort of job-heavy growth of manufacturing, it's impossible. It's never going to happen because we have to figure out a way to cut costs dramatically. And really the only way to do that is through these kinds of technologies we're talking about. So, yes, sir.
Thank you so much. This question is a bit more financially oriented. And so, Austin, I mean, this might be a bit directed to you. So as, you know, it's kind of like a self-sustaining issue with lack of investment into American industry and manufacturing currently is causing it to kind of decline, be an uphill battle to get funded and high growth American manufacturing and industrialization going on. How do we get these banks and financial liquidity providers to start investing in America even if they see quicker, faster, easier money elsewhere?
Austin?
Well, look, I'd love to talk to you about it offline. There's a huge swing that I think the government can play here. Kev, if you want to talk about that great article that you introduced me to a few years ago from the co-founder of Intel there in the, because I think that's an important part of this picture.
Sure. I mean, I think the Office of Strategic Capital right now, you know, has a role to play in providing capital. My own view on government policy is that there actually now is, you know, fully commercial digital engineering and manufacturing. The real roadblock is simply saying to people, you now not only need to recognize this capability, you need to be able to say the processes, the airworthiness requirements, all of the different things that were set up for a completely different industrial base now need to quickly change. Because if we don't do that, there's an instant in time right now where we actually have the digital technology where we can do hardware development and building as fast as software, but there's a whole structure that needs to be changed along with it that's at the middle layer of the defense industrial base. And if we do that, I think the rest of the commercial base will follow that.
Next one. Yeah, I couldn't agree more. I think, in my own view, I think we got 10 years. And after 10 years, we become the UK. And when you're the UK, you got no hope left. I'm sorry if anybody from the UK. You got no hope. You're not going to reindustrialize. It's super hard to reindustrialize when you got nothing or when you got very little. But we still have a lot. But to your point, this is moving super fast. And so we've got to really be agile, and finance is a key part of that.
Could I just add one thing to that? I mean, we've all seen the number. Wall Street Journal just had the article that showed in 2000, we had about 26% global manufacturing market share. That's trending toward 11%. China in 2000 had 7%. It's trending toward over 40% in the next 5 years, not 10 years. By the way, those were the numbers that, by that time, the UK had around 10% right before the Second World War. The US had 45%. That's why we were able to wake up and step in. We don't have 10 years. Yeah. We've got 5 years.
I was trying to be nice. Thank you. We got 5 years left, and then we're all going to be speaking British. If you have a really short question, we'll just fit it in.
Sure. I'm in government doing regulation and safety, and we've been told we should deregulate, streamline things, do performance standards. I'm wondering, do you have any advice for doing that quickly? Is there any way we can, across FDA or DOT or health, like streamline how we do performance standards in a way that could unlock more or faster industrialization?
Come talk to us. We've got a massive amount of data generated by 6 major automotive OEMs that can be applied across industries. And you need to have data-based processes, testing, airworthiness, validation based on fully digital systems. We have a program that we're doing right now with multiple government agencies on that. Look us up, we can tell you about it.
Also, for what it's worth, my colleague David Hart wrote a long report for some government agency a few years ago, looking at everything we know about the structure of regulation and the impact on innovation. And there's a lot of lessons from that. we talk about what some agency have done that seems to work, so I'm happy to get that to you. So we have to stop because a really, really important panel is coming up next. So this was a great panel. I wish we had more time. There's so much depth here and so much things to go into depth, but so please join me in thanking a great panel.